Hey, fellow problem solvers, Colfax Math here. Today we're working on math test success, making you as successful as possible on any standardized math exam, specifically the ASVAB. I've had a lot of students come to me to figure out how to really boost those scores and do better on math exams. Maybe they've been out of the game for a while, kind of forgot a lot of things. So I built this course with the idea of you being successful as possible on any math exam. So it is a 25-chapter book. You could join the channel and be a member, get early access to those videos. You could download the book for free at mathtestsuccess.com, or you could buy the book on Amazon. But you need to have paper and pencil out in front of you, taking notes as I go through the overview, refreshing ideas on math, and then you need to pause the video and do the problems before I do them. That's really the best way to get it to stick in your head. You can't learn to juggle by watching juggling videos, just like you can't learn math by watching me do it. You really have to do a lot of practice problems to get this stuff sorted out. Today we're looking at our last chapter, chapter 19 on content. Chapter 20 is about test-taking strategies. 21 through 25 are all practice tests working on different test-taking strategies. So this is really our last chapter on content. These are really common problems in the arithmetic reasoning portion of the ASVAB, as well as the mathematical knowledge portion of it. These are pretty tricky problems. We have rate, distances traveling to and forth, that classic problem where you drive your car this far this way and this far, where do you end up? We have mixture problems which come up a ton in standardized tests. And all of those, you kind of need to know the tips and tricks. So this is a good chapter review before any standardized math exam. So with all that said, let's go ahead and get started with applied algebra and real world scenarios. These rate, time, distance problems are really common. The equation is distance is equal to rate times time. So I always think about this, if I forget it, is I always put units in there. So if we're talking about a car, our distance would be miles. Our rate would be miles per hour, right? And our time would be hours. So when I have it written out like that, I could see that hours would cancel and miles equal miles. There are three variables in that equation. You have to have at least two to solve for the third. So as an example, if a car travels 60 miles per hour, that is a rate for 3 hours. That is a time. How far does it travel? Well, we have distance is equal to rate times time. This is saying how far does it travel? It is asking you for a distance, how far. So D equals RT. So I know 60 miles per hour times T, 3 hours, is a total distance of 180 miles. And again, MPH means miles per hour, right? So let's erase that, miles per hour, and then miles per hour times hours. My hours cancel, and that's where those miles come from. Here's another example right here, example 2. So we have distance is equal to rate times time. Let's see what we have here. A train travels 240 miles in 4 hours. What is the average speed? So I am asking for rate here, and I could do this two ways. I could solve for rate in this equation, or I could just plug those in. Distance is 240. Rate is what I am looking for, and time is 4. I divide both sides by 4, and I get the rate is 60 miles per hour. The key is really decoding the sentence, but if we're working with this, we're just looking for those three variables. All right, pause the video, do that example, unpause. How long does it take a plane flying at 500 miles per hour rate to travel this amount of miles? That's distance. Plug that in the equation. 1250 is equal to the rate 500 times the time. I have to get t by itself. I divide both sides by 500. These cancel, So I have T by itself. 500 goes into 1,000 twice with 250 left over. 250 over 500 is a half. So it goes in twice with 250 500ths, or 2.5 hours. So those are distance, rate, time problems. We're going to look at some more of those, but now we're combining motion. And again, these are really common problems on a standardized math test. So if they are moving towards each other, then the combined rate is equal to the sum of the individual rates, right? So if I'm going 50 miles per hour this way, someone is coming 50 miles per hour this way, how far are we approaching each other? At 100 miles per hour. If we are moving away from each other, right, I'm going 50 miles per hour this way, 50 this way, then we are leaving each other at the sum of that, or 100 miles per hour. And then if I'm traveling this way and somebody else is traveling the same direction faster, then how far apart do we get? We're traveling apart at the difference between blue and red. All right, let's take a look at this one right here. Two cars start at the same point and travel in opposite directions. I'm going to say one's blue, one's red. One car travels at 50 miles per hour and the other at 60 miles per hour. How far apart are they after 2 hours? This is a rate, miles per hour. They're traveling apart. So after 1 hour, they're traveling 110 miles apart. So after 2 hours, I take that 110 and I multiply it by the 2 hours to get 220 miles apart. Okay, section 19.3, work rate problems. The work is equal to the rate times the time. So this will be hours. This will be hours per job, and then the work. Very similar to what we were doing earlier, but different variables now. So let's take a look at this first one. John can paint a room in 4 hours. So he can paint one room per 4 hours. So what is his work rate? His rate per hour would be 1/4 rooms per hour. So that would be his work rate, 1/4 room per hour. If Mary can complete a task in 6 hours, I better write these out here. So Mary can complete a task in 6 hours, and John can complete the same task in 3 hours. How long will it take them to complete the task working together? Well, it takes her 6 hours, so she could complete, she rates it 1/6 per hour. He's working at 1/3 per hour, one job per the 3 hours. To add them together, I need a common denominator. I multiply this by 2/2, so I have 1/6. I'm going to multiply this by 2/2 to get 2/6. I add those together to get 3/6. Right? Adding fractions, you have to have a common denominator. So that means their work rate is 1/2, meaning that they could complete the job in 2 hours, right? They could complete the whole thing with that rate, 1/2, which gives me 2 hours. Okay, moving right along here. Mixture problems. These are classics, and these aren't really very easy, but let's go ahead and take a look at them. So how many liters of a 20% acid solution, we'll convert that right to a decimal, must be mixed with 10 liters of a 50% acid solution to attain a 30% acid solution? So X is going to be the number of liters of the 20% solution. So we're going to call that X. And then what we want to do there is we are saying 0.2 of whatever that is. It's saying how many, so that's where the X comes from, plus 0.5 of 10, so we have 0.5 times that 10, and that is going to be equal to the amount here and the amount here times that 30%. So that's equal to 0.3 times the amount here and here, x plus 10. Let me clean this equation up here a little bit. I have 0.2x, 0.5 times 10 is 5, is equal to 0.3x, 0.3 times 10 is 3. Keep my x's positive. I'm going to bring 0.2x over here, subtract 0.2x from both sides, get 0.1x, subtract 3 from both sides to get 2. I'm going to have to divide this by 0.1, divide this by 0.1, x is equal to 20. So the amount of this solution is 20 liters. These are hard. And really the hard part is converting this sentence to this equation. Once you have that equation, solving the equation. Okay, let me move this up a little bit here. For example, 2. So you got to look for keywords. I am selling coffee for $6 per pound. And tea, so I have coffee for 6, tea for 4. How many pounds of coffee should be mixed? So I don't know how many pounds it should be. They're asking me how many pounds. So I know I'm going to call this x. So I'm saying 6x. How many pounds of coffee should be mixed with 10 pounds of tea? So plus 10 pounds of tea to create a mixture that sells for $5 per pound. Well, this is the price of coffee. This is the price of tea. And I want to know, I know my price is 5, but I don't know how many pounds. So price of coffee plus the price of tea, we want that to equal $5 times the total amount. Well, the amount of coffee is x. The amount of tea is 10. So I go from my equation, from my sentence to my equation. So I'm going to solve this equation. 6x plus 40 is equal to 5x plus 50. Solving the equation, I'm going to get all my x's on the left. Subtract 5x from both sides to get x. Subtract 40 from both sides to get 10. So x is equal, oh, good Lord, x is equal to 10. The key to these problems is really set up the correct algebraic equation. You want to spend some time doing that. Really identify what it is that you're given, right? And what it is that you are looking for. And then solve that equation. Take that value, plug it back in to check. Okay, we are on test chapter 19, rate, time, and distance. Go ahead and pause the video. Do these problems before I do them. Unpause the video and check how you do against mine. So right here, I'm reading this rate. I am given a time, how many, and I'm looking for distance. So I could tell I'm going to use this equation. Distance is equal to rate times time. The rate is 75. The time is 2.5. There, and that's going to be my distance. So the answer here is 75 times 2.5. I can multiply that out, or I could just do 2 times 75, 150. Half of 75 is going to be 35 plus half of 5, 37.5. So here's my 2, here's my half to give me 187.5, and this is going to be miles. Number 2, a runner completes a 10-mile race in 2 hours. I'm given distance, and I'm given time. What is the runner's average speed? That's going to be the rate. So distance is equal to rate times time. I divide both sides by 2, and I get a rate of 5 miles per hour. Number 3, 2 cars leave the same point and travel in opposite directions. So I start here, one's going this way, one's going this way. One car travels at 45 miles per hour, the other at 55 miles per hour. I know that they will be 100 miles apart after 1 hour. So This plus this gives me 100 miles per hour. Multiply that to find distance after 3 hours. My hours are going to cancel and give me 300 miles. Correct answer, 300 miles. Number 4, a plane travels a distance in a time, that's a D. In a time, what is the plane speed? That's a rate. So distance is equal to rate times the time of 3. I divide both sides by 3 to get a rate of 500 miles per hour. And really the goal here is, these are pretty easy ones, and you could probably figure some of these out without using the equations, but I'm hoping they all make enough sense so you could take that skill set and apply it to harder and harder problems. Okay, problem number 5. Hopefully you're still here working away. Person A can complete a task in 5 hours. So in 1 hour, they complete 1/5 of the task. Person B can complete the task in 10 hours, or in 1 hour, they complete 1/10 of the task. So then I need a common denominator, add those together, multiply that by 2 over 2 to get 2/10. This is already a common denominator of 10. So I have 2/10 plus 1/10 is 3/10. So their rate combined is 3/10 of an hour. So I'm going to do 1 divided by 3/10. 1 divided by 3/10 is like multiplying by the reciprocal, right? So that's equal to 1 times 10/3, which is just 10/3. 3 goes into 10 3 times with 1 left over, or 3 hours and 20 minutes. 1/3 times 60 gives you 20 minutes. Okay, a pool can be filled with 1 pipe, we'll just call that 6 hours, and another pipe in 8 hours. How long will it take to fill a pool if both pipes are used? This is actually the same as this one. It's a tricky one though. So it is filling the pool in 6 hours, or 1/6 of the pool in 1 hour, 1/8 of the pool in 1 hour. I need a common denominator, 12, 18, 24. This will go into 24. Multiply this by 4 over 4 to get 4/24. This by 3 over 3 to get 3/24. Add those two together to get 7/24. And then it is 1 divided by 7/24, which is going to be 1 divided by it like this, will be 24/7. Then I can reduce that, or no, I can't. 7 goes into 24 3 times with 3 left over, so 3 3/7 of an hour. And that, I mean, that's a ballpark number. That kind of makes sense there. Okay, number 7. How many liters of 15% salt? How many? I don't know. So I go 0.15x must be mixed with 5 liters of 40%. So I do have that amount, 5 liters of 40% to obtain 25% of the total amount. 15% of x, that's the amount of this solution. This is the amount of this solution. The amount here is that plus that, or x plus 5. It is hard to convert that into this. These are really one of the most classic style of hard math problems, are these mixture problems. So let me simplify this equation. 0.15x plus 0.4 times 5 is 20. Move the decimal place over once, so 0.15x plus 2. Got to distribute this through the quantity. 0.25x plus 1/4 of 5 is 1 1/4, I think. 1 1/4. combine all my x's. I always try and keep them positive, so I'm going to subtract that from that to get 0.1x over here, right? This from there. I'm going to subtract that from there to get 0.75. Solving here, I'm going to just move it over 1 and move it over 1 here to get x is equal to 7.5. So that's 7.5. Okay, I think maybe we should end it here. These last two problems are down in the key down below, so they're right in the book, but I don't want to chew your ears off. These are similar to the ones up above. So if you're still here, well done. The more you study, the better you're going to do. That's just the way pretty much everything always works. Any questions, please post them in the comments. I'll get to you as soon as I can. Make sure you have paper and pencil out in front of you. I mean, the best case scenario is you bought the book on Amazon. The next best case scenario is you downloaded it for free on mathtestsuccess.com. And then the next scenario after that is just have your own notebook and pencil and do the problems. That act of writing them out really helps a lot. You might have to revisit this video a few times, rewind it, do it a few times, especially these type of mixture problems right here. They're just tough. But when you have those techniques that I went over, they're easier to figure out. Well, thank you for watching, and we'll see you on the next one. That'll be a test.